This conference will now be recorded.
Good to go.
Thank you, Liam, for that introduction, and welcome everyone this evening. I hope you're not too disappointed not to have Peter talking tonight. So if you were expecting to see Peter and you don't want to demonstrate that you've left and just walk away, and I won't know and I won't be offended. But yeah, hopefully I can deliver Peter's slides in a suitable way. They won't be quite in Peter's format, and those of you who know Peter know he has a particular way of giving this type of talk. But it is good for, good opportunity, and I'm really pleased to be able to stand in for Peter and give this talk to the Nottingham Derby Section, both the PWI and the IET, and it's good that I'm a member of both. And part of the PWI's drive at the moment is to increase its membership, particularly in the area of electrification, and to become the home of electrification engineers. Peter is now president-elect of the PWI, and part of his drive is to really increase the membership in that direction. And as part of that, he is spending quite a bit of time touring the country, giving talks to encourage electrification. And as part of that, we've got, as Liam mentioned, a fairly significant conference in Glasgow next month that has been planned for some time and unfortunately has had to be postponed on 2 previous occasions. So fingers crossed this time it will go ahead and it will be a good opportunity to promote electrification and the PWI. So if there are members of the IET on the call who are not members of the PWI but have an interest in electrification, then you are welcome to the PWI, and we're certainly looking to sort of strengthen and make PWI a natural home for electrification engineers who tend to not really we have a presence in the IET. We also have a presence in the IMechE. So quite a bit of the work we do is more civil engineering related, so it overlaps across institutions. So having a home within the PWI, I think, will be a real strength. So please give that some consideration. So on to tonight's talk. If I can get the slides to click on. There we go. So as I say, these are Peter's slides that I'm going to talk over. So hopefully I can give them due justice and credit. So talk a little bit about the history of electrification, particularly in the UK. So that's the past. Where does electrification sit in the context of the 21st century? And its significance now, and why is it still relevant, having been around for many years, and where are we going in the future? What are the challenges and where are the opportunities? So I've worked with Peter and have known Peter for many years. That was his statement about preaching too much, but hopefully the same applies, and you are interested in what Peter would have said and what I will be saying. So why do we need electrification? For those of us who have made a career of it, it's been a really interesting and challenging career. And we have this sort of inbred in us that we know that electric trains are cheaper, they're quieter, they're cleaner, they're lighter, and do less damage to the rails, the ballast, the sleepers, the infrastructure generally. More powerful in terms of the power and the volume that's given, and operationally more flexible. Some people might challenge that and say, but they can't go anywhere. You've got to have the wires there. But there is a lot of operational flexibility. And if all that is true, why isn't the whole network already electrified? And that would seem to be an obvious question, but unfortunately in this country there are many reasons, and so looking back at history can give some indication as to why we got to the situation we're in now. So these pictures probably aren't that unfamiliar to many of you. The railways, where did they start? Right back in the 1840s, when we started developing railways as we know them today. A lot was owed to Isambard Kingdom Brunel and George Stephenson, names from history that everyone knows. Stephenson's strength was very much in the practical engineering. Brunel was much more innovative, but neither of them lacked ambition and were fundamental predecessors in our industry that resulted in a significant amount of the network that we now have inherited. Brunel particularly, though, knew that energy efficiency could be achieved if the engine was part of the infrastructure. So this is looking at the railway as a whole system, and this is a fundamental part of what we do within the PWI now, I believe, is looking at how is the railway part of the system. And Brunel really understood that and looked to see how could the engine and the infrastructure be all interrelated. One of his solutions was the atmospheric propulsion. So the atmospheric railway, unfortunately, it failed because it leaked. But it was looking at that understanding of how do you move vehicles without necessarily having to carry all the load of the energy on board. And the atmospheric propulsion railway was part of that sort of concept. But moving on, coal was the solution, steam was the solution in the 1840s. But it wasn't too long before the birth of electric traction came along. Unfortunately, this was too late for Brunel. But in 1879, Siemens demonstrated the first practical electric locomotive. This was picked up and further developed by Westinghouse in America. So some of you may think of Westinghouse as signaling engineers, but Westinghouse did actually develop the electric locomotive. When it comes to the UK, there are two key engineers that were involved. So Sir Vincent Raven was the chief mechanical engineer of the North Eastern Railway, and he collaborated and had a long collaboration with Charles Mertz, who was part of Mertz and McLennan, who were another North Eastern engineering consultancy. And they developed a number of electric railways in the North East, the Tyne Electric, Harton Colliery, Tyne Docks, and Shildon Newport. And the foundations of pretty much all that's developed since in the UK is based on that original early development in the Northeast. And just not to undermine, there are pictures of Sir Vincent Raven and Charles Mertz, who were key to the development of the railway in the electric railway in the Northeast. And here are some pictures. So in the top left, we've got the Tyne Electrics. That was a third rail conductor system with the not that dissimilar to what we've got in the southern region and on Merseyside now, and lasted for best part of 100 years. Harton Colliery was also electrified with overhead line system and Tyne Docks, and I believe that picture in the bottom left is of Tyne Docks. There were two of those locomotives built for shunting vehicles around the docks. And then the bottom right is the Shildon Newport locomotive, again an electric overhead line locomotive. That system ran at 1500 volts DC. And the Shildon to Newport was starting to develop into quite an extensive route with the as shown there on that map. And for those of you familiar with the Northeast, will recognise some of those places, I'm sure. So going out to the Tees, and basically it was for coal movement was its primary purpose. So from the last years of the 19th century, electric traction really began to develop. The conductor rail system grew rapidly, particularly in the south. OLE, overhead line systems, with both high voltage AC and DC were put into service. Quite a few railways developed developed electrification systems, and you can see them listed there, particularly the North East Railway that we've talked about, but the Midland Railway also, LSWR, Lancashire and Yorkshire, and significantly the London, Brighton and South Coast Railway actually installed some overhead line electrification in South London. So there is still some evidence there of the overhead line structures in the CES, but there was over 100, best part of 100 years ago, some overhead line equipment in this on the southern. But by the outbreak of Second World War, in the UK, the Weir report had set out to standardise to two different alternative traction systems. So the third rail conductor rail system at 750 volts, which was growing in the south in particular, and then the 1500 volt overhead line DC system, which was the standard on the Northeast Railway and was seen as the longer distance preferred system. The LNER at this stage had also commissioned work on the Great Eastern between Liverpool Street and Shenfield, and also linking in to Fenchurch Street, and had plans for the MSW across the Pennines. But that was then all put into perspective with the Second World War. So although the networks were starting to develop and starting to expand, unfortunately war came along and put paid to that. But we can see that there was early recognition that electrification systems had a future, were likely to succeed coal and steam in many places and within the pre-war era. Railways went through a pretty torrid time, and I'm sure there are many of you on the call listening in tonight who know far more of the history than I do. But come 1955 and after nationalisation, the British Railways era, the British Transport Commission published a modernisation plan, and electrification of the network was a key part of that. But diesel was seen as an interim measure to bridge over between the steam days and into a fully electrified or a pretty extensive electrified network. And the plan at that stage was for most of the routes in the UK to be converted to an electrification system by around 1990. So 30 years ago, we should have had a pretty full electrification system. Initially, 1500 volt DC was the standard, but post-war austerity maybe rings a few alarm bells, but post-war austerity killed off the electrification plan and dieselisation became the norm. So with BR coming into existence, the GE lines were completed to Shenfield and works progressed on the Transpennine, Manchester, Sheffield and Wath, an advanced stage of development that they had been started before the war and then were completed. And BR progressed these schemes, but at the time, different forms of electrification were starting to emerge in Europe and appeared to have some economic advantage. So AC systems were appearing, and particularly the French approach developed the 25 kV overhead line system. And in 1956, there was a conference of the UIC as well as another in 1962. And BR, or the British Transport Commission, determined that BR should adopt the 25 kV system for mainline use going forward. The 750 volt DC systems would remain where they were and would be adopted and further expanded in the areas, particularly on the south of the Thames. But new electrification, as a general rule, would be the 25 kV AC overhead line system, and the 1500 volts DC systems were then effectively superseded. So the modernisation plan started but was only delivered in part. In 1962, the 25 kV actually started to demonstrate the economic values as well and preferences over the 1500 volt DC. And the main line from Euston to the north was started. Where have we seen this before? Euston, Manchester, or since Euston, Manchester and Liverpool started running late, started going over budget. Overspend alienated the Minister for Transport, and electrification was halted. and unfortunately there were real problems, and eventually BR had to address the cost challenges to enable the West Coast to be completed to Glasgow, which wasn't completed until 1973. So there was a stop in the programme, a real loss of momentum, and British Rail spent a lot of time really trying to work out how could they deliver cost-effective electrification. So what British Rail did in that period was actually, in hindsight, quite phenomenal and transformational. The need for much better project planning was recognised. And the West Coast mainline was the first project where, outside of America, critical path analysis was used and adopted as a way of planning the project and programming it. Another strategic principle that British Rail introduced was route rationalisation, re-signalling, and then electrification. So route rad, resig, then electrify became the mantra. And the principle here is that if you're doing a route upgrade, and normally when you're looking to spend significant amounts of money on a route, there's an opportunity for improving the infrastructure first. So rationalise the infrastructure, plan your new layouts, make those changes, then re-signal, and then at the end, when all that's been done, come in and electrify the network. Don't try and do it all at the same time. Don't try and get all the different disciplines on top of each other. Have a sequenced upgrade of any route. And that was the process that British Rail adopted, but we appear to have forgotten about and forgotten the advantages and the reasons for that, maybe in some more recent drives to get electrification accelerated. Furthermore, British Rail looked at every component of the electrification infrastructure and thought about how can we do this more effectively, more cheaply. So significant efforts went into the redesign and the integration into a production process, which relentlessly looked at reducing the cost of every minute part. How can we use less nuts and bolts in the air? How can we change the way the installation works? How can it be turned into a production process? And the Weaver Junction to Glasgow was the first to apply the benefits of this new way. Some of you may be familiar with the overhead line, different types of equipment, and the Mark 1 equipment was what was adopted on the West Coast at the south, and the Mark 3A was what was adopted for Weaver Junction to Glasgow. What happened to Mark II, you say? Well, the principle of Mark II was around reducing the number of tools, so trying to make all the fittings the same size, so you could have one spanner, and there's a fair amount of Mark II equipment in the Glasgow area on the Glasgow Suburban. But the big step change was the introduction of Mark III equipment on the West Coast Main Line between Weaver Junction and Glasgow. And these measures brought forward the most successful and cost-effective delivery that we've ever achieved. So rolling on from the Weaver Junction to Glasgow, there was then extensive further electrification in East Anglia. The Midland Main Line from St Pancras to Bedford was electrified. There were problems there with the introduction of the new stock when it was completed, and many people will, I'm sure, remember seeing fleets of trains sat in sidings because there were challenges. I believe it was union issues in introducing the new stock, but the cost of the electrification was very successful, and that then rolled on to the East Coast Main Line, and eventually reaching Edinburgh and across into Glasgow in the early 1990s. So the most significant and cost-effective introduction of electrification that we've ever seen in this country. So British Rail published a plan in 1977 that was the pre-runner to that. Option 5, I don't know the details of all the options, I'm afraid, but option 5 was selected, which was for wholesale electrification. 25 kV equipment, as I've said, the overhead line system was selected, and 11% return was demonstrated and had full Treasury backing. Unfortunately, May 1979, there was an election. The Conservative government came to power under Margaret Thatcher, and the plan changed. HST and APT then were developed in parallel. Some problems with the APT, particularly the infamous press run on the west coast, resulted in HSTs winning out, and so diesel for high-speed routes was selected as the preferred short-term option that then extended right up, and HSTs are still operating, as we know. Unfortunately, option 5 only got delivered in part. Schemes in Anglia and Scotland were completed. East Coast Mainline was also completed, and that was perceived by many people to be BR's greatest electrification success and the UK's greatest success when it comes to electrification. But when it was completed, privatisation was coming into view. Signalling took the attention of Railtrack and then Network Rail in its early days. Electrification was perceived to be too expensive. There was a lot of talk at the time with some fairly influential people of why do we need to go to electrification? In the UK, we've got the advantage that we've never spent all this money on all this expensive infrastructure around the country. We can leapfrog the electrification era and go straight to some clever new fuel supply that might be hydrogen, might be something else. And certainly there was a lot of discussions in the early 2000s about hydrogen was going to be the saviour of the railways. But there's a lot of evidence that supports why that is not the case. It's going to be part of the solution going forward, but not a full solution. But anyway, electrification became off the agenda. Electrification capability in the UK, a lot of engineers went overseas. I was one of them. The work in the UK was focused more on refurbishment, so the West Coast route modernisation. There was significant electrification work on that, but it wasn't major new electrification. So after the East Coast Main Line, there were some smaller projects, the Birmingham Cross City, the Leeds Northwest going out into the Airedale and Wharfdale electrifications, but that was the main part, and then the Heathrow Express. But other than that, there was very little new electrification. Then things started to change again, and I was involved in writing a paper for the Department for Transport in the 2008. And in 2000, Network Rail were very much involved in reinvigorating a programme and putting together a new programme of electrification that was announced, and a new plan was announced in 2010. The intent was to have a rolling programme to electrify the network, and at the time there was full and enthusiastic backing from the Department for Transport. Many reasons why. The industry as a whole probably took on too much in a very short time. Were suckered in maybe to the number of pound signs that were left dangling. The whole industry said, yes, of course we can do that, because nobody likes to say no to the boss or to the hand that feeds you. And if money is going to be put towards further electrification as an industry, we didn't want to say no. But we know what happened in CP5, the cost in the programme overrun, alienated ministers of transport and electrification. The brakes came on very rapidly partway through the West Coast, and while the Midland Main Line was still in early stages of infancy, and the Northwest as well was never completed with the full package of works that were envisaged at the start of that programme. So Great Western was put on hold and only partially completed. The wires did continue to Cardiff via Bristol Parkway, but not the main line into Bristol, Temple Meads, and also no further from Cardiff. We never got on to Swansea. So the Bath route was not wired, although going round towards Bath, there is a significant amount of structures. And if you go under around the Chippenham bypass, it always frustrates me that there are these structures stood up on the embankment there, but with no wires on. So a lot of money was spent, but we never actually delivered. Schemes in the Northwest and Scotland were delivered potentially more efficiently and effectively. Certainly in Scotland, plenty of claims that that they were delivered at a much cheaper cost than in England, but the problems with the Great Western in particular being very high profile overshadowed pretty much everything else, and the brakes were applied. So coming to the present, that history has got quite a few lessons. Right from the start, electrification has been the obvious superior solution to railway traction. Peter would say that, he's an electrification engineer. I would say that, I'm the same, but there's a huge amount of evidence that actually backs that up, and it's basic physics. At the end of the day, you're not carrying around huge fuel tanks and energy converters in the same way that with electric traction you do. So each and every scheme has proved to be transformational when it's been delivered and is a success in operation. There's no doubt now, certainly in my mind, I think you'll find the operators and the public agree that where you've got electric trains on the Great Western, they've transformed the journey there. I appreciate some people might complain about the seats and the trains themselves and the way they've been specified, but the electrification infrastructure has generally been a great success. When I was earlier in my career, the sparks effect was often talked about, and that still is evident. And the Midland Mainline with the Bedford to Kettering and Corby extension as well has been able to transform that railway. So electrification schemes do have significant benefits. Passengers, railway, businesses, communities all experience those benefits, and we actually fairly quickly forget some of the pain of that conversion process. That's not to underestimate the pain that some people went through and the disruption that has been caused through some of the electrification programs. So one of the challenges we must take and the lessons we have got to learn is how to make it less painful. So although Great Western was one of the more painful projects, hit the news for too many reasons too often. The choice, I don't think anyone would like to go back to an HST, although I appreciate that there are a few people who always want to go on an HST anywhere and everywhere, and they may be actually more comfortable in some respects than the current electric fleets, but in terms of the service they provide, the technical aspects, the electric trains are far superior. So these electrification schemes have all created a significant change, and it's not just in the UK. There are a few photos from Peter's collection here that some of you may be able to recognise. The one on the top left, I believe, is from the London, Brighton and South Coast Railway, just not far from where Peter lives in Balham. So that demonstrates that the southern region did used to have an electric overhead line. The bottom left is the latest UKMS Master Series, so the UK electrification system. In the middle, you've got a Mark III headspan arrangement, so that the British Rail very lightweight system. We can see why there were significant cost savings. There's plenty of debate around the reliability of that system and how much of that is due to and understanding the balance between whole life costs and capital costs. East Coast was delivered for a budget and was delivered for that under that budget, and part of that was to reduce the costs, but it was understood that it would need to be maintained, and whether it's been given the tender loving care through its maintenance life that it was should have had is a debatable point. Then some other pictures, I'm not sure where they all are. The top right, I believe, is in Denmark, and the bottom left is in France, I believe, and that demonstrates that not all electrification has to be as ugly as some people perceive the Great Western to be, and those arch structures are very environmentally friendly, as you can see by they also host the nest of quite a large bird. So as you can probably see, there's a bird stood on the top of that structure. So not only is electrification environmentally friendly because we're not burning fossil fuels, but we also provide roosts for birds. Which brings nicely on to where we are today and the climate challenge. There are still some skeptics about, but nearly all scientists agree that we've got to stop our dependence on fossil fuels, that climate change is real and that it's man-made and it's a consequence of pumping carbon dioxide and other gases into the atmosphere. So how do we respond in the UK? And looking at the UK rail industry, hydrogen has a role. I would say maybe more than might. I believe it has got a real role to play, but it's never going to provide the motive power for mainline heavy haul. Batteries also have a role. I believe primarily in a transition period, but also longer term for some more remote routes, lightly used. But the actual capacity of batteries still is not as great as some people would like to think. They don't perform nearly as well in cold weather as they do in the hot, and there are challenges around that, and quite often they get rated and suppliers try and sell the positive elements and features of the batteries and keep a bit quieter on the poorer performing conditions in which they may be expected to operate. And what's more, they rely on rare earth metals and the challenge of obtaining some of those metals for those that watch markets. I believe that the price of nickel has gone through the roof recently because there's a worldwide shortage of nickel. So there are real challenges with battery technology, and it doesn't get away from the fact that you're carrying around on your train a significant weight. So a lot of your tractive effort goes into just moving the batteries before you start moving your passengers or your freight. And currently the range is around 50 miles. You can extend that by putting more batteries on, but then you take up more and more of the space. So realistically and economically, 50 miles is a typical range for a battery electric. So full electrification is the only real solution, and particularly for freight. World is changing. Climate change is here and now. Don't need to emphasize that. There's plenty of evidence. We've experienced plenty of rain just recently, high winds. National governments, including the UK, have committed to net zero by 2050, and that's now a legal requirement here. How do we achieve net zero? A net zero, and I come back to the point I made earlier about systems. This has got to be a whole system. So the whole of the world effectively has got to get to net zero, not just one bit of it. We can't all just do our own little bit. And part of that is not only converting the railway to make sure that it's not net zero. We have the technology now to be able to make it zero, totally zero, not netting it off by counter effects, by planting more trees to absorb that last little bit. The railway can be totally zero emissions. What's more is there's huge potential for the railway to help other transport systems. So why aren't we doing more to get modal change, and particularly in the freight market? So I think there are huge opportunities for freight going forward and modal shift, which will require even more electrification, not less. What that might do, though, is shift the emphasis from being on the rail to from passenger routes to the freight routes, and looking to see where freight operations can go. Apologies, I've got problems with my PowerPoint. I can't move the slides on. Let's try that. There we go. So traction decarbonisation is as much about the railway as it is about other modes of transport. So transport decarbonisation is a real challenge for the UK. There has been some talk, well, why don't we just electrify the roads? There's plenty of very good reasons why that will be impracticable. One of which is if you've got some overhead line running down your motorway, how do you get in with your air ambulance on those occasions where you need to get an air ambulance down? And there was one idea that, or one challenge that was flagged up to me just recently, having looked at all sorts of the other practical challenges of electrifying highways, not least of which is all the legal implications and liabilities and maintenance tolerances, and if there is a rip down, who pays for it, and how disruptive is it, and how safe can it be? One of the advantages of the railway, we still use steel rails. They form part of the traction return and safety system. So if the wires come down, we can immediately get a good earth, we can protect the system, and it's a safe system to operate. If you're on the road and the wires come down onto a bit of tarmac, which is not a good conductor, it's very difficult to then isolate. The amount of power that would be needed to power those HGVs, which may start all bunching up and acting effectively as a road train, is pretty significant as well. That would need some huge traction power substations, roadside substations at very frequent intervals. So the practicality of the physics of operating on the road without all the controls involved is significant. So how do you, a key part, as I say, is freight. Network Rail published the Traction Decarbonisation Network Strategy, which is an excellent document that has been that sets out a long-term strategy for how we can electrify the majority of the UK network, but not all of it, recognising that there are some elements that it just would never be practicable to do, and that's part of where battery and hydrogen can come in. But that strategy, and if we're to meet the 2050 commitment for net zero carbon, proposes nearly doubling the route mileage of the existing electrified lines. So that is significant, but it sets a course. In order to feed that, the grid and distribution networks are changing. Traditionally, we've been reliant on predominantly coal-fired power stations that, not surprisingly, are not too far from the coal fields, a lot in the Midlands and the north of England. We then distribute through high voltage systems to users. That is all starting to change as we move away from coal-fired power stations. Offshore wind turbines in the North Sea and Irish Sea and anywhere else, if they're offshore, by definition, they're not near the centres of population. So we've actually got to start moving that power in different directions. So that creates large challenges for the distribution networks. What's more, with solar power and wind power onshore, it's much more distributed, right down to individual private houses. Whereas up until very recently, people would have the power supply coming in from their local transformer into their house and they would use it. That was it. Now, more and more houses are built with solar panels where they can bring electricity in from the grid in the same way, but also have the opportunity to export excess power that they generate through their solar panels. So it changes the whole network of the grid, and that's a real challenge. So part of the railway tapping into this changing network is making sure that we're planning for a long period and a 30-year horizon. So the picture will look very different in 2050. Traction demand will likely more than double, and even more if there's greater modal shift, and Road vehicle charging and domestic heating also will have greater demand on that electrification, on the electricity supply in the UK. So additional generating capacity, significant extra, is also needed. So it's important that the railway works with the generators. What do we need to do? First and foremost, we must rediscover the sense of purpose that British Rail showed in the 1980s. And Don Heath, who was the project director for the East Coast Main Line, headlined his completion report 1 year early and under budget. And that's unfortunately nothing we've been able to write about electrification projects in recent years. So we've got to be able to get back and find a way of getting back to that situation. Senior leaders of the industry, and these are Peter's words, so I do tend to agree with them, but they're not my words, so I am reading them. Senior leaders must have the humility to admit that the mega project bureaucracy is not fit for purpose and has led to some of the overcosts. And I do agree that we need to be looking at how can we break down some of these really big projects. They do lead to the famine and feast that we've seen. We had a huge amount of electrification in CP5, then it dropped off a cliff. We're at risk of repeating that if we're not careful going into CP7 as demand and the demand for further electrification increases. How can we reduce that so it's more evenly spread and a smoother ramp up that is then sustainable in the long term and doesn't suddenly get into that position where the money runs out? So we need to adopt a change in culture that really does focus on that, not just on cost, though cost is a key part, but also value for money and recognizing the difference between cost and value for money. So some future challenges: need to move to net zero by 2050. Transport is going to be a major contributor to that, and the rail must be a key part of that. Private cars likely to reduce in number, but will remain battery powered, possibly some hydrogen, but there will be a demand for electricity from cars. Diesel lorries, much harder at the moment to see how they're going to convert and where they're going to transition to. So more freight will likely be needed to be transported by the railway. And therefore, as I said earlier, the railway needs to be carbon neutral, not just net zero by 2050. The traction decarbonisation strategy has identified a plausible way to achieve that. It is a strategy and will need to be to evolve as it gets delivered, which is recognised by the authors. But the significance of the amount of route that needs to be electrified is key. And these challenges need to be addressed now. Otherwise, our railways will be part of history and we'll be letting future generations down. So coming to the end of the presentation now, Peter's final message was the railway now has a chance to move to wide-scale electrification, and I agree, and I'm doing what I can to help promote more and more electrification in a cost-effective way and understanding how the whole pipeline is going to work, that we can get to some significant repeatable levels of electrification in the future, but we can't just turn it on the tap overnight. So the railway needs to grasp this chance and secure its place in transport future. If we don't, then the whole railway could well die, because if we can't make it carbon neutral, or at least a significant part heading to that net zero, then there will be no future. And if we repeat the failures of history, then we'll get into those positions where we're behind schedule, we're costing too much, and there won't be the funding. So like all aspects of climate change, the challenge for the railway is existential. We have no choice. We must make this change. So on that note, I'd like to thank you for listening. I hope I've been able to pass on some of Peter's views, but certainly some of my own. Hope that's been worthwhile, and I'm happy to take some questions.
Great, thank you. Thank you for that, Paul. So we've got two questions in the chat. First is from Graham Clark. Don't know if Graham wants to unmute himself and ask the question himself, otherwise I shall read it out.
No, it was an observation as much as anything, Liam. This amazingly heavy OLE on Western, has it proved more reliable during all the storms we've been having?
It's still fairly early days, I think, but my understanding is yes. it is very robust, and it has withstood the storms. How it compares to other systems, I'm not sure, and there's much more to understanding the robustness and the resilience to higher winds than just the size of the structures. One of the challenges we have is we still get trampolines blowing onto the overhead line in these storms, and no matter how robust the system is, I think that they're unlikely to withstand that sort of thing. And there are other reasons why we might need to close the railway in very high winds and storms. But generally, yes, I do believe in that aspect, the Great Western has been very successful, and it has been proven to be to date very reliable.
Okay, thanks.
Thanks, Graham. The next one from Alistair Hughes. I'm not sure if it's a question or a comment. Do you want to ask that, Alistair?
I can see the question. I think I hinted at that, and I know the 800 class aren't considered the most comfortable of trains, and I would share some of that, and I do like the comfort of an HST, but I think from a whole system, from an engineering perspective, electrification is superior, and has been hinted at with the robustness of the equipment on the Great Western. The challenge is for us to work as an industry and make the whole railway more attractive, which includes making the passenger environment all the way through any passenger's journey as comfortable and as pleasurable as possible, and putting people on long distance trains on hard seats, looking at a pillar and not being able to see out the window and that sort of thing doesn't contribute to that. So I do have some sympathy there, Alistair, with your comment.
Thank you. Richard Hill, next question.
Hi Paul, how you doing? You all right? What do you think the biggest barrier is going to be to electrification? Because you're saying that we need to almost double the route mileage that we've got in, let's say, 28 years to 2050. I've spoken to different people at different times about using bimodal trains to bridge the gap. So electrify where you can now, where it's easy, where you've not got to do gauge changing and track layering and stuff like that, and then fill in the gaps as we go along, as we've got more time.
Yes, as I said, I think batteries and hydrogen have got a role to play, including in the transition. The existing diesel bimodes we've got also can play a part, and certainly there's quite a lot of work looking at how effectively they can play their part. One of the problems we've had regularly, and certainly with the in the last few years, is some of you may remember Cameron and his Chancellor, his name escapes me, Osborne, stood up in Manchester and said, we're going to electrify between Manchester and Leeds by 2018, I think it was, or whatever the date was, without us having really developed any system, any scheme, knowing quite what the project was as an industry, and we were hit by that end date, and anything after that was seen as a failure. With the use of bimodes, and we're starting to see it on the likes of the Midland mainline now, where bimodes are likely to be introduced, you can make use of the electrification infrastructure as soon as a small section of it is available, and then run on the diesel bimode function beyond where those wires are. So one of the key challenges that we have in all our areas within the railway and elsewhere is how do we reduce carbon, and this is how we need to look at the larger picture, the whole system element, as well as our individual little bits. We're challenging ourselves as electrification designers as to how can we reduce the carbon content of the equipment that we build and design. But the most significant benefit from electrification is achieved on day one, when you stop running diesels under the wires and you can use that electric traction. So we can make lots of little savings and hopefully some bigger savings, but actually the most significant bit is the decision to make is to electrify and then to get electric traction operating as soon as possible, as is reasonable. So we need to start moving away, I think, from having big programs dictated by timetable changes that drive all sorts of behaviours. One of the things I look back on the Great Western and see how the cost time quality triangle was never really in balance, but moved from one point of the triangle to another, and then to the third point through the history as the main drivers changed. If we haven't got that deadline, you must have it done in time for a timetable change, but we can introduce electrification earlier stages, then that will help. But ultimately, the biggest challenge at the moment is getting electrification down to an affordable level, and it's not just on the cost of the equipment and the materials, it's looking at every aspect in a similar way that BR did. So looking at the procurement methods, looking at the possessions, looking at how much access we have to the railway, what is the most effective and efficient way, whilst remembering we've got customers ultimately at the end, be they freight or passengers. So it's part of what Peter mentioned in his slides, I totally support, is looking to how can it become a much more production process. How do we turn electrification into production engineering rather than lots of project engineering, and move away from this concept of projects to just having a rolling program that it gets very boring and very dull almost. We're doing the same thing night after night, putting in foundations, putting up steelwork, running out wire. We get so far, we connect it to the supply, energize it, run trains. Let's move on to the next bit. Let's get it into that sort of dull, repetitive production rather than it's a nice big new shiny project and it then will fall under the radar, won't hit the headlines in the same way, and I believe will be more cost effective. But at the moment, there's a risk that we go for this seesaw effect. It's boom or bust, and that's driving costs as well. So I haven't answered your question directly, I'm afraid, Richard, because there are a number of barriers, but the key one at the moment is getting the costs down and keeping them down.
When you talked about the production on the GWR, though, they did look at having a production train that did the foundation digging and all that sort of stuff, which did entirely as planned. Would you say that's still a viable option on different routes to take
very much so? And it frustrates me that there's a lot of money was spent on some highly technical plant that sat in a siding in Swindon doing nothing, and some of it is even I'm told up on blocks with the bogies taken out. We've got to make use of all our assets as best we can and use that, and how much more effective can that be? If that is just going out night after night, chipping away at it, doing a few more foundations, maybe it's not there were problems in the early days with the piling train not matching the piles, but we've learned a lot from that. We've overcome most of that. We're not trying to put in 8-meter piles these days. We've learned some lessons there, and we must make sure we continue to learn those lessons. And I do believe that is a key part of how we can move into that sort of production level. Because how much time do we spend putting on and railing and derailing mutes in a relatively short possession rather than actually making the best use of that time? If we could have a quicker way of getting the equipment so that as soon as the last train has run, we can be their operating plant, which with more mechanised plant that's more suited to running in traffic, there are, I believe, are some options there as well.
Thank you very much, Paul.
Okay, we've got 3 more questions if we've got time. See how we go. So Tim Butcher was next.
Yeah, hi, thanks. I suppose my question relates a little bit to what was being said before, but the industry's challenge to get to 2050 is of course great. Without that top-down political will and policies and ultimately funding, that's challenging. So I just wondering if there's any knowledge of what is coming out of Downing Street, Whitehall, etc., in terms of helping enable what you've presented.
I think it's we're at a fairly sensitive time. There is recognition that, and it's in law, that we've got to achieve net zero by 2050. How we actually achieve that, electrification unfortunately isn't very sexy. It doesn't really, So it's not modern technology. There's a lot of modern technology that goes into it and that we can use, but the basic principles have been around for well over 100 years. It doesn't suit politicians, flag waving, ribbon cutting type events, and grandstanding, and it takes time. So there is a political challenge, and that's tied into the costs as well. I think there's a general acceptance and a lot of work that's been done in the last few years promoting all the benefits and the reasons why electrification is the solution are generally recognised, but there's still this scepticism. Yes, but we can't actually afford it. You've got to get the costs down, and not helped by the post-COVID scenario, troubles in Eastern Europe and Ukraine, how that might hit the treasury, cost of living prices that they're going to have to cater for. So that cost challenge, I think, is key, and that's why politicians would like to think there might be an alternative, and will pursue alternatives. Why we have to continue to argue the case and demonstrate why electrification is not only the right solution, but is a cost-effective solution as well. And that cost-effective element is by getting that price down, that cost down, that unit cost.
Thank you.
Okay, next was David Learmonth.
Thanks. It was the southern region. Do you run out more third rail? Do you cover everything overhead? How do you transition between one and the other, or do you have dual-powered trains?
So I think where we are now, we're unlikely to move. We need to spend our efforts electrifying the non-electrified lines rather than going back into the southern region and electrifying with the overhead where we've got the third rail. A few years ago, there was quite a lot of work done to look at what could be done and the process for converting, particularly with concerns from the ORR of the danger of having live equipment at ground level where workers can be readily exposed to it. But I think the reality now, and there was some work that indicated that you could possibly transition at the time when your power supply system needed replacing, you could transition to an overhead system, not that much more expensively, because the power supply systems for an AC overhead line system are cheaper than replacing and converting all or updating all the power supply system on the third rail system. I think we probably missed that opportunity in this generation, and with the need for greater electrification elsewhere, I think that's where the work needs to be spent. In terms of dual voltage vehicles, yes, there are more opportunities. Thameslink is a classic example of where that operates. There are opportunities for more of that potentially. A lot of the trains from the southern have been designed with AC electrification in mind and to operate as dual voltage systems. When we start looking at more tram train systems, there are some possibilities there, quite how we may integrate in the northeast, because the Tyne Metro is a 1500 volt DC system. There are some challenges there. So dual voltage trains, yeah, do have a place, I think, but my view at the moment would be that let's focus on electrifying non-electrified routes rather than spending time and effort converting the third rail systems.
Okay, now our very last question comes from Bill Andrew.
Hello, yes, it's just a thought. I just wondered whether Brexit might give us the opportunity to go back to the old BR day electrical clearance requirements, because I understand they have caused some additional costs, particularly in some of the electrification schemes in Scotland.
I'm not sure that Brexit is necessarily the reason, but a lot of work has been done in the last few years to address the challenge of the amount of civils and structural reconstruction that has gone into electrification projects, and that is a significant factor in the cost of electrification. So the Danes developed or used a system that has been adopted in the UK now and has now become the standard. And this was driven primarily by the Cardiff intersection bridge, for anyone who's familiar with the railway in Cardiff, where the line from Queen Street into Central comes up and over the West Coast main line. And to raise that bridge was very, very expensive with the vertical alignment of the Queen Street lines, and was not really practicable. So the other option that we would normally look at then is, well, how do we lower the track under the bridge? And we couldn't do that either because there's a canal that runs underneath the railway at that location as well. So the constraint on the railway was significant. So a lot of work has been done to bring down to what are now lower than BR clearances, and we believe they still comply with the European standards. And you might hear the term VCC, which is voltage controlled clearances. So primarily by using surge arresters to limit the peak voltages on the overhead line that occur as a result of lightning strikes predominantly. And that is what has driven a lot of the electrical clearances on these structures. By putting in electrical devices that can control that, as well as looking at the way we insulate and provide additional insulation to the system and the actual structures themselves, we've been able to bring down the clearances considerably to an extent where in a lot of cases now the tolerances that we have to allow for mechanical clearance to stop the pantograph physically striking the bridge of the same order of the electrical clearances we're applying to for electrical reasons. So don't believe it's as a direct result of Brexit, but I do believe we've now got solutions that are significantly reducing the number of structures that are being rebuilt, and that is already being applied on the latest stage of the Midland Main Line. It's being looked at for the Wigan to Bolton electrification in the northwest now. So yeah, that is something that's been taken forward.
Oh, thank you.
Okay, thank you
I've
very
overrun.
much for that.
Apologies.
No, that's fine. Thanks very much for that Q&A session. So we've just got two things left to do. Andy Packham would like to propose a vote of thanks.
Yeah, right. Well, a really excellent talk, and gave us a great sort of canter through the context, relevance, and importance of railway electrification. I was particularly struck at there's quite a nifty slide. I think it's the third slide. So the electric trains are cheaper, quieter, cleaner, lighter and less damaging, more powerful, more flexible. Plus a bit later on, 11% return. I think that was the late 1970s report. So it's all pretty compelling, and yet we know that there have been lots of hurdles and false starts and setbacks along the way to what hopefully where we'll hopefully end up with a fully electrified railway system. So it's been a great talk, saying to sort of put over why we are where we are now and where we need to be and why in the future, particularly with the climate emergency and a fair amount of how we might get there as well. So yeah, a fantastic talk. And Paul, I thought you kind of, I know it's Peter had put the talk together, and unfortunately wasn't able to give it, and we're so grateful for you for standing in at very short notice to do this, and I think if you'd have claimed that those were your own words, we wouldn't have noticed, and I'm sure Peter would be proud of the way you presented all of that. So thank you very much indeed. Now I know Liam said he's got something else to do to finish this off, but it's traditional at this point for everybody to unmute their microphone, put their camera on, and give their thanks in the normal way. So if people could do that, put your cameras on, unmute your microphone, and let's give all a vote of thanks. Okay. you.
Thanks, Andy. So yes, the last point was just to invite David Phillips from the IET. I think had some technical difficulties at the start of this and wasn't able to speak to us. David.
Liam, thank you. It's David Phillips, the IET Derby Notts Group. I want to just say thank you to the PWI for inviting the IET to participate in this evening's webinar. And I thought it was an excellent summary, as Andy's just said, but it was an excellent summary of the rail electrification on the British network. I'm sure there are some attendees had some flashbacks at some of the references that were made, but I hope it is also useful to younger engineers to provide context for their careers as well. So thank you very much, and I hope we can look forward to future collaboration as well. Thank you.
Great. Well, thank you very much to everyone for this evening, and I wish everyone a pleasant evening. Good night.
All right, all. Liam, what committee members do you need?